In urban traffic management, vehicle and pedestrian signs and markings form the foundation for the operation of order. AI identifies vehicle types, traffic flow, and pedestrian position, behavior characteristics, and captures in real-time abnormal situations, such as illegal parking of motor vehicles, non-motor vehicles, illegal driving, and pedestrians walking onto expressways. Drones are on the elevated bridges of the main roads in the city center. Banks' AI cameras can identify car types, buses, and other vehicle models in real time, count the density of traffic flow, and detect abnormal congestion and traffic accidents in real time. Once a traffic accident occurs, the most crucial thing is to handle it quickly and restore road traffic at the accident scene. Compared with the past, when traffic police had to go to the scene to collect evidence, nowadays they only need a drone to quickly fly over the scene and use AI algorithm to automatically complete the accident. The image acquisition and data plotting drone adjusts the gimbal vertically downward to take a top-down view of the undynamic situation. When an accident occurs, AI can automatically identify the fallen personnel on the road markings, zebra crossings, and roadside green belts. It only takes a few seconds to quickly generate an accident scene map to assist traffic police in accurately determining responsibility. The high frequency of illegal parking of motor vehicles in cities and insufficient police coverage have always been difficulties in traffic law enforcement inspection through drones. The AI comprehensively judges the situation of illegal parking on the sidewalk walkway based on the duration of stillness, parking location, and road attributes. All vehicles that occupy the bus lane and illegally park on the emergency lane of the expressway will be recorded in real time. The GPS coordinates and license plate numbers are reported to the traffic management platform to achieve rapid evidence collection and precise law enforcement. In addition to regular vehicles, high-risk vehicle types, such as hazardous chemicals, oil trucks, transport vehicles, and dump trucks, require a more stringent travel control system based on vehicle type recognition and license plate detection screening, especially for sections subject to time period restrictions at night. Once illegal entry is detected, a warning for non-motorized vehicles will be immediately generated. The car is the most flexible but also the most difficult to control AI algorithm in the transportation system for cars without helmets. Based on the features of human heads and helmets, it can identify people who are not wearing helmets. As for dangerous behavior such as electric bikes entering main roads and illegally crossing the road, or even overloading, AI can be used to focus on supervision in high-frequency occurrence areas. Not only is precise statistics of vehicle flow and pedestrian flow equally important, but also in densely populated areas such as pedestrian streets. Once the AI detects a sharp increase in the number of people in a local area or a prolonged stay, it will trigger a warning through the system to reduce the risk of sudden incidents, such as stampedes. Inside the bus, the AI device can also count the passenger flow of each route and feed it back to the bus dispatching platform to adjust the schedule in a timely manner. The in-vehicle AI terminal can detect the driver's blinking frequency in real time. Abnormal behaviors, such as the amplitude of yawning. When signs of fatigue are identified, the system will remind the driver to take timely breaks to prevent fatigued driving. In remote mountainous expressway sections, wild animals occasionally appear. When crossing the road, answer, I can identify animals that have strayed onto the highway. Immediately, the traffic management department was informed to carry out in-fonde eviction. As the tunnel is a section with closed space and difficult escape, the system needs to dynamically monitor the traffic flow to identify and detect non-compliant vehicles entering. Whether abnormal parking in the tunnel indicates the occurrence of flame scattering within the tunnel to prevent minor accidents from evolving into major disasters. In the field of rail transit, when metro trains enter or exit stations, answer, I can detect the status of the train doors. Once any abnormalities, such as choking a person's stomach or tight closure occur, an alarm will be triggered promptly. Notify the station staff that on the escalator if someone is dragging large luggage, the AI can also promptly detect it and prompt them to change and pass the path, prevents the risk of falling. In the operation of high-speed railways, I can also assist in checking the appearance, grooming, standing posture, and gestures of train attendants to ensure the standardization of services. I can also automatically identify and statistically analyze the mask wearing and wearing conditions of waiting passengers, cooperating with public health management strategies to achieve intelligent prevention and control. For road and bridge maintenance departments, achieving daily efficient inspection and maintenance of road conditions through AI is the key to preventing accidents and saving costs. There are various types of road surface diseases, whether it is transverse cracks, longitudinal cracks, or potholes. Answer: AI algorithms can accurately mark the location of the disease, distinguish the type of disease, and even accurately determine the length and area of the crack through segmentation algorithm by analyzing road surface images. The health condition of bridges is equally complex. For instance, in terms of structural cracks, answer: I trained through customization can accurately distinguish between natural cracks in the joints of structural components. As for the prefabricated blocks of the bridge body, critical diseases such as damage to falling nodes, expansion joints, blockages, or deformations can also be identified in real time and their locations marked. The disease information captured by AI is transmitted to the cloud maintenance platform, which automatically conducts statistical analysis and outputs disease detection reports, enabling the intelligent maintenance of roads and bridges to be based on precise data. In the ground support process at airports, algorithms have also been pushed to the forefront. The identification of the connection lines between the airport runway trajectory and the jet bridge to check if they deviate from the path helps the command personnel adjust and dispatch. Coupled with the identification and distance measurement of irrelevant personnel in the runway area, it truly achieves the safety of closing the loop before the aircraft takes off. As a core means of transportation for port shipping, it is a key supervision target. Vessels carrying hazardous chemicals are strictly prohibited from entering the ordinary operation area without declaration. Once a leakage occurs, it is very likely to cause an explosion and water pollution. Drones with visual AI capabilities can automatically identify the hazardous chemicals labels on the hull during port inspections. Quick location of the vessel number. Hazardous chemical vessels are compared with the AIS system through their vessel numbers to jointly warn whether the vessels have entered the port illegally. For the port dispatching of ordinary ships, different types of ships correspond to berths and loading. Moreover, the methods are different. Cargo ships and carrier ships need to be equipped with cranes for hoisting operations, while passenger ships need to berth at professional berths with protective facilities. AMAR, I can detect the type of ship based on the shape characteristics of the hull and guide the statistics of ship berthing. In addition to the detection of the ships themselves, for bulk materials such as sand, gravel, and coal transported on cargo ships, if the hatch covers are not closed during navigation, it is highly likely that dust will be raised, polluting water bodies and injuring crew members. The AI structure is unattended. Conduct inspections to enable supervisors to remotely detect cabins that are open and issue timely warnings. AI can also check whether the designated national flag is hoisted at the ship position to prevent unlicensed vessels from attempting to enter the port or operation area. In addition, regarding the safety of personnel on board, AI can also identify the status of crew members, those not wearing life jackets, and look out personnel leaving the port to sleep, etc. In fact, based on the water environment itself. Answer: AI also has many applications worth empowering. The disorder of river channels and river management is a key challenge in water affairs management. Traditional reliance on manual river patrols is inefficient, has a limited coverage, and is prone to oversight and supervision nowadays through regular flight inspections by drones. Combined with the precise and high-frequency identification of visual AI behaviors such as random tramping, piling, and chaotic construction, taking illegal sand mining and illegal fishing as examples. AI detects targets, precisely identifies and integrates specific equipment such as sand dredgers, excavators, and fishing boats, locate the job position, and quickly identify illegal activities. Similarly, the problem of random garbage piling in the chaotic river channels has also been a headache for the management department. Especially when the flood season comes, the garbage piled up everywhere drifts around, not only polluting the water body, but also potentially blocking the flood discharge channels. At this time, Answer I is needed to identify the location and type of garbage, and the recorded data will be sent to the River Management Department for cleaning, reducing the risk during the flood season, and for instance, privately setting up sheds and trellises along both banks of the river to enclose land and pile up materials for occupation. The disorderly construction phenomena in the riverbank buffer zone, or the temporary construction of storage sheds, can also be quickly identified and marked by AI to assist the Urban Management Department in handling them in a coordinated manner. Of course, it's not just the issue of the four disorders, the safety of the shoreline, equally important. For instance, during the flood season, it is particularly necessary to pay attention to the water level height of the river. The AI system can monitor the water level changes near the water tower in real time. Once an abnormal increase is detected, the Water Conservancy Department will be immediately coordinated to initiate an emergency response. Similarly, this technology can also be applied to the monitoring of water level lines on ships. When the ship docks, when approaching the camera, the device captures the water level in scale markings. Through target detection and OCR technology, it quickly identifies the draft depth of the vessel, avoiding the risk of overloading and overturning. After all, the core of shoreline safety is still personal safety. For instance, in areas prone to swimming accidents, such as beaches or rivers, drones have become lifeguards in the air. Timed cruise uses abnormal behavior detection algorithms to automatically monitor swimmers in the water area for any drowning or unexpected situations. Some reservoir areas are inherently off-limits to outsiders. Once someone illegally approaches the cameras set up at the far end of the embankment, it will be determined whether an intrusion has occurred. Notify the management department immediately to stop it in time. In addition, the removal of floating objects in rivers should not be ignored, especially when there are too many floating green plants. It can easily lead to deterioration of water quality. However, the colors and shapes of green plants are diverse, which greatly increases the difficulty for AI recognition. Therefore, a large amount of scene data needs to be trained to accurately identify and push them. The cleaning department, while the issue of floating garbage in the river involves more complex factors. For instance, the garbage may be confused with water plants, branches, or even the reflective ripples on the water surface, leading to misjudgment by AI algorithms. At this point, the AI must undergo more meticulous training to accurately distinguish between garbage and natural substances, and connect with the urban management system for precise retrieval, thereby avoiding causing pollution on a larger scale. River debris is just the tip of the iceberg that affects the city's appearance. Every public space may be littered with garbage everywhere, especially exposed garbage, along roads or in industrial parks, which can easily cause secondary pollution in windy weather. However, drones can accurately and quickly mark the location and quantity of garbage during high-altitude patrols, allowing sanitation workers to simply disrupt the city's storm. There is still an extremely high risk of collapse and electric leakage carried by unmanned aerial vehicles. Once AI algorithms identify foreign objects or abnormal structures across the roof and locate the coordinates of illegal constructions, they can quickly carry out rectification for street stalls. AI can determine whether they have crossed boundaries or blocked passageways. By combining time, period, and regional management rules, it can promptly intervene in problem restaurants without interfering with the normal business operations of compliant vendors. Water accumulation under bridges is also a risk point in cities. When facing sudden weather conditions, the algorithm can pass under railway bridge tunnels and other medical areas, divide the area and depth of accumulated water to make arrangements for urban early warning and traffic detour. Of course, the identification of flames and smoke is the top priority in emergency management. Burning straw in the suburbs, though just a wisp of smoke, may develop into a large-scale spread. Sudden open flames in smoggy residential areas pose a greater threat to personal and property safety. This is an AI algorithm that can capture smoke in different scenarios. The morphological characteristics and spread directions of fog should be identified and controlled in key areas, such as urban fringes, urban-rural structural areas, and densely populated residential areas to achieve early identification and early reporting. In addition to public areas, many industrial parks and factories have installed a large number of traditional cameras at the beginning of their construction. Relying on manual monitoring to detect fire situations is not only inefficient, but also prone to missed detections. Now, as long as it is connected to the AI Edge server, there is no need to replace the equipment, and the old camera can also have remote recognition capabilities. For instance, in the processing plants and laboratories of various industrial parks, there are often obvious signs. Fire-igniting operations and the stacking of flammable materials can spread extremely quickly once they catch fire. At this point, it is necessary to utilize AI to detect the flame patterns, such as bright flames, smoke, fog, and fire points in the working area. The algorithm can also accurately identify sudden situations such as vehicle smoke and abnormal heat sources in the open areas around the park, such as the vacant land on the periphery and the surrounding parking areas. When the system detects an abnormal fire point, it can further trace back the monitoring records. Track whether the fire source is caused by human activities to provide a basis for determining the fire delivery. In new energy vehicle charging stations, the characteristic systems such as battery, thermal, runaway, and often accompanied by thick smoke and light spots, can promptly identify abnormal smoke and guide the on-duty personnel to quickly use water-powered fire extinguishers for emergency response. In key regulatory areas such as chemical plants and industrial parks, due to the limitations of large factory areas, complex terrain, blind spots of cameras, many traditional monitoring methods often find it difficult to achieve. Comprehensive coverage is achieved, while drones can patrol along flight routes. High-frequency scanning calculation of multiple fire points take into account the concentration to predict the development of the fire and achieve aerial control. In addition to identifying open flames and thick smoke, it is also necessary to keep a close eye on potential hazards and take preventive measures in advance. For instance, the clutter piled up in the corridor not only affects the environmental hygiene, but also blocks the escape routes. Answer: an intelligent analysis of the clutter accumulation helps the property management make precise rectifications. Aim: I can also identify the daily operation and maintenance status of fire extinguishers, whether their placement is compliant and their appearance is intact, and whether there are any light ones. Any abnormal issues such as missing parts should be reported directly once discovered. The ultimate goal of intelligent emergency response is the identification of personnel behavior. In gas stations, the smoking actions of people are captured to prevent explosion and fire accidents. In the production workshop, behaviors such as smoking and making phone calls by employees are judged, and the behavioral records are used as the basis for safety management assessment to achieve the preemptive prevention and control of risks. Risk prevention and control have shifted from behavioral propositioning to process closed-loop management, and the safety management of industrial parks has also begun to enter a systematic stage. In the operation workshop, the AI needs to determine whether the employee is wearing a safety helmet, wearing work clothes that meet the standards, and wearing black safety shoes. After confirming that they have entered the computer area, the system will identify whether the gloves are worn completely, to confirm whether the protection is in place, ensuring that every time they enter the operation area, they meet the most basic safety protection standards. And once you start the assignment, the degree will then enter the identification of personnel status, whether the staff are on duty, whether they are dozing off or temporarily away from their seats, and whether their sitting posture is abnormal. Once an abnormal status is detected, the system will synchronously remind through the background to enhance the operational stability of the work section. Before entering the operation area, the AI needs to check whether the employee has touched the electrostatic ball to ensure that the static electricity has been released before the operation. It can also identify in real time whether there is any leakage in the production area and whether there is any liquid accumulation on the ground. At the same time, like the fire hydrant pump cabinet, the AI for firefighting equipment will also determine whether it is in a shutdown misoperation or an abnormal state. Electronic fences are often established for control in specific hazardous areas within the park. For instance, when there are undetectable behaviors such as unauthorized personnel intruding or illegal excavation in the park, the system will quickly identify the anomalies and immediately coordinate with the park management bente to stop the potential unknown dangers. For dangerous actions, such as attempting to climb over walls or facilities, the system will quickly identify and issue warnings to prevent safety accidents. According to the security check area at the entrance, the key points and postures of personnel passing through the security check are analyzed by AI, which can determine in real time whether the personnel are accepting the security check in the prescribed posture, whether there are situations such as obstructions or illegal carrying of items, and automatically complete the matching of personnel identities with entry and exit records. In the warehousing link of the park, the system can also identify whether forklifts are driving and parking in the prescribed area. Avoid confusion in your homework. The internal system of the IT computer room in the park is designed to monitor the safety operations of the on-duty personnel. Effective measures should be taken to prevent operational risks, such as whether two people are working together and whether one falls when working at heights. To ensure the stable operation of equipment and the safety of assets, the computer room is often in a closed environment. AM monitors the opening and closing status of the door in real time to avoid the influence of temperature fluctuations and dust invasion inside the computer room. Safety management is also a key regulatory focus in the smart construction site industry, especially in terms of workers' compliance with dress code. Construction site workers are constantly shuttling between different locations for operations, and the construction area is filled with a lot of debris and equipment, which can easily lead to obstructions and fixed surveillance. Due to the limitations of installation locations, it is easy for supervision to be inadequate. However, drones have the ability to be deployed and withdrawn quickly. There is no need to pull a set of equipment such as network cables and wires. They can even be used to rotate through multiple construction sites, greatly improving the efficiency of operation and maintenance. It is installed in different key areas within the construction site, such as the tower crane operation area, the steel bar processing area, and the temporary road passage area. AI algorithms identify whether workers are wearing safety helmets, reflective vests, professional uniforms, and other equipment properly. Even in high-altitude operation areas, the algorithm can automatically identify whether safety belts and ropes are fully worn to prevent accidental falls. In the operation area of large equipment, before workers start mechanical operations, AI can also monitor whether there are other people near the untrained equipment. If there are any abnormal situations around, it will issue timely warnings to prevent heavy machinery from accidentally injuring people. AI can identify, classify, and statistically analyze the types of construction sites and heavy machinery, the total amount of current operating machinery, and analyze their start and stop status and frequency, providing management with a more comprehensive construction profile. For the governance of the construction environment, a general segmentation algorithm can be utilized to calculate the area of bare soil not covered at the construction site. Abnormal areas for preventing urban dust and soil pollution will be automatically marked and located, providing quantitative basis for environmental protection acceptance. AI can also identify water accumulation in low-lying areas of construction sites, track changes in water body boundaries, promptly detect potential hazards, and address leakage issues at the interfaces of water supply pipelines and cooling pipe openings. AI can identify abnormal signs, such as water stains and dripping water, promptly detect leakage, and avoid any impact on concrete pouring and infantile safety. In addition, for the behavior management at the construction site, the entry and exit of personnel on the construction site can be recorded through black and white list facial recognition to prevent abnormal personnel from entering and leaving. In the construction of smart campuses, in the classroom, answer. I can identify the number of students, and in the initial stage of intelligent roll call records, it can also determine whether students are concentrating on listening, calculating the class rate, and whether there are states, such as sitting at desks, daydreaming, and playing with mobile phones. Provide data support for classroom order management. In the examination room, answer. I can also assist in identifying whether there are significant abnormal behaviors, such as being picked up by traffic or turning heads for a long time, thereby reducing supervision. Teacher Gao's burden of achieving low-interference continuous examination supervision and deterrence. AI is also quietly changing the way physical fitness tests and movement guidance are conducted in physical education teaching. For instance, in physical education tests, algorithm can precisely count the number of rope jumps and support multiple people to simultaneously detect and record individual performance differences. And for events such as pull-ups, supine, and sit-up basketball, combine posture recognition with standard models to determine whether the movements are correct, standardize the scoring and feedback to help students adjust their movements in a timely manner, and improve the training effect. The same mechanism has also been extended to online fitness classes. AI can recognize various types of fitness movements, such as burpees, jumping jacks, single leg squats, high leg lifts, and combination punches. By capturing key points of the human body, it can automatically determine whether the movements are in place and provide technical suggestions and count the repetitions, helping users calibrate their postures and improve training effects. It also serves online coaches, teaching authority scoring and feedback, provide quantitative basis. As for the highlights during sports, I can also accurately record and analyze them. For instance, for technical movements in basketball, volleyball, badminton, and other sports, frame-to-frame recognition is carried out. The wonderful moments are directly compiled and captured for record, and key data such as the shooting percentage and hit points are statistically analyzed to assist coaches in reviewing performance. And for sports, such as skateboarding, fencing, and football, it can further identify the details of the athlete's movements, extract the movement trajectory, analyze elements such as the takeoff angle, sprint, rhythm, landing, and stability, and be used to form a complete movement technical report. The precise recognition of AI algorithms has also given rise to many astonishing AI products. For instance, in a dance machine, algorithms can identify the key movement points of dancers, determine the degree of movement completion and the fit with the rhythm, and achieve precise and scoring feedback. In the snooker scenario, the system can also conduct global modeling of the table, identify the ball shape and landing path, track and output each hitting process, the player's score and the changes on the table surface, and achieve intelligent recording and rematch statistics of the game. These scenarios are just the tip of the iceberg of how Gongland has helped various industries implement the value of AI over the past 5 years. We have witnessed that AI is no longer a luxury for leading enterprises, not just a demonstration concept in the laboratory, but is permeated and seamlessly integrate with the devices around people in every corner of factories, coal mines, industrial parks, farmlands, campuses, and homes, creating tangible and real changes. The Gongdadi Auto email automated training platform is becoming an accelerating engine for the implementation of AI storage benefits across the entire industry, aiming to bridge the technological gap, transform complex alvarez production into a standardized assembly line, and enhance the efficiency of AI innovation and delivery to an unprecedented extent. Every enterprise builds its own AI,